Okay, so we are on lesson 3.2 still, and this is the last part. It is actually some real world situations, and the note sheet is available for you to print off. If you haven't done so, you certainly can, and if you don't have that capability, you can just write these in your spiral notebook or just write the problem. First and foremost, for some reason, when we copied this, it ended up with the same thing twice. Sorry about that. You don't need that bottom half. It's the exact same three problems. So we're going to define the variable, write an equation, and solve. So there's actually three parts. A, define a variable. B, write an equation. And C, solve. We're going to use that word problem breakdown. The very first job to do, I guess you want to say, on the word problem breakdown poster is to underline the question. So it says, suppose your high school baseball team scored 5 runs in Saturday's game. This was 4 more than half the runs scored by the opposing team. How many runs did the opposing team score? And the beauty of starting with the question, and a lot of times in algebra, it will give you what your variable is, what you're looking for. And it says how many runs. So your runs is your x. So anytime you see the word runs, you know you're going to replace it with an X. All right, so word problem breakdown, we're going to go ahead and circle our numbers. So when we circle our numbers, we're looking at something like, suppose your high school baseball team scored 5 runs in Saturday's game. This was 4 more runs than half the runs, there it is, runs, which is your X, scored by the opposing team. All right, now we're going to go back through and we're going to look for our clue words. So suppose your high school baseball team scores 5 runs. Well, actually scores is going to indicate an equal sign. 5 is going to go on the other side. And it said this was 4 more than. More than means addition. Then half the runs scored by, and by means multiplication, the opposing team. So when you're getting ready to write this equation, so we got to define the variables first. We'll do that first. But when you're getting ready to write the equation, you have to keep in mind that this was under the section referring to solving multi-step equations. So when you write your equation out, going to be an equation, it's going to have an equal sign, and then it's going to be at least a 2-step equation or more. So a 2-step or more. All right, so we have to define the variables. So to define our variable that we're talking about is X, which is referring to runs scored by the opposing team. So A. X is equal to runs scored by the opposing team. Now, a lot of times when I'm grading these, I give story problems multiple points. The answer is great, but really, to be honest, I'm more interested in the setup. So I really pay attention to your defining your variables and writing equations, and I a lot of times give points for all of those different parts. So keep that in mind. I don't want just an answer. I need to see all of those parts because that's one of the things that you have to leave me with is knowing how to take a real world search situation and write an equation. So B, we're going to actually write an equation. So B says it was 4 more than, so I can just see 4 and then plus, kind of tells us what exactly we need, half the runs scored by, half the runs scored by. So half by, which means times, half times runs X. So that would be 1/2 X. You can leave it as a fraction, you can change it to a decimal, 0.5X, whatever works for you. And then scored 5 altogether, so equals 5. So that's the equation, something I'm going to be looking at, all right? And then 3, or C, it says to solve. So I'm going to go ahead and isolate the variable, which means I have to get rid of some guys hanging out there. So I'm going to subtract 4 to the other side. And that gives me 1/2 X equals 1, because 5 minus 4 is 1. Now I'm going to divide by 1/2, or divide by 0.5. And dividing by 1/2 is the same thing as multiplying by 2, if you know that trick. If not, you could put it in your calculator, but dividing by half is the same thing as multiplying by 2. So 1 times 2 is 2. So that's the answer, but you haven't quite done C yet, because whenever you answer a real world situation, you have to include a story problem, not a story problem. You have to include a label for your story problem. So what does this 2 represent? Well, you know it's 2, and then X stands for runs scored by the opposing team. So this would be 2 runs were scored by the opposing team. And as I look at this, again, kind of 3 parts. First part, define the variable. So let's see, what do I have for colors? Maybe I'll make this a kind of a light purple. So define your variables. So define your variables, and that's what I was doing here. This is defining my variables. B, we had to write an equation. So maybe I'll make that green. So I need to write an equation. So B is write an equation, and here's my equation being written. And the last part is C, which is solve. We'll do that in orange, and C is solve, and that's what I'm doing here, actually attaching a label to what it represents. So 3 parts. Here we go, number 2. In a catalog, tulips cost 75 cents each, and shipping costs are $3. Write a rule that describes the amount spent as a function of the number of bulbs ordered. Then determine the greatest number of bulbs you can order for $14. So again, start with the question. That's what word problem breakdown tells us to do. So then determine the greatest number of bulbs that you can order. So what don't we know? We don't know how many bulbs we have. So that's going to be our X. That's going to be our variable. So let's see what else we got. We know that bulbs cost 75 cents each. We know that shipping costs are $3. And we know that we spent a total of $14 altogether. So what else do we need to check out? Well, we said that they're 75 cents each. Each is a clue word meaning multiplication. And shipping costs. So here's one of those situations where and means you're going to get 75 cents for each bulb that you buy. You're going to get charged that. And a one-time fee of $3 for shipping costs. So here that and means addition. And then it says, write a rule that describes the amount spent as a function of the number of bulbs ordered. Is there anything in there that we need for our equation? There isn't. This is extra information. And so when I have extra information, I just cross it off, get it out of the way. And then it says determine the number of bulbs. So that's our X. That's what we need to know. You can order for, and there's my last clue word. For, in this case, means equal, $14. That's going to go on the end. So part A says define your variable. So what does X stand for this time? X stands for, it's right here, number of bulbs. And just so you know, a tulip comes like in a little bulb that you plant in the ground. So we're not talking like a light bulb that you plug in, but it's like a little plant because you're talking tulips. So now B, we need to write the equation. So it says tulips are sold for 75 cents each. Well, how many are we going to buy? We don't know. So that's our 0.75x. And then, and shipping costs are $3 plus $3 equals a total of $14. Very important on the setup, making sure that you know how to set up the equation. Okay, so now we're going to go ahead and solve this. I'm going to go ahead and do this. I'm going to subtract 3 to isolate my variable. And that gives me 0.75x equals 11. Now I'm going to divide both sides by 0.75 to isolate the variable. And x is equal to 11 divided by 0.75. So when you get 11 divided by 0.75 in your calculator, give you a second to work that out, but you would get 14.6 repeating. Now, this is a situation where you have to interpret the remainder, meaning, are they going to ship you, this catalog company, this tulip company, are they going to ship you 14.6 repeating bulbs because you had $14 to spend? So you can't afford a full bulb, and you can only afford 0.6 repeating of one. Will they send you just 2/3 of a bulb because that's what 0.6 repeating is? No, they won't. What would that even look like? Oh, let's slice the bulb right here. That's not going to work. So based on you had $14 to spend, you're only going to be able to get how many bulbs? It's either going to be 14 or 15. Do you have enough money to get 14? No. If you had exactly $14, you can get exactly 14.6 repeating bulbs. So you can't get 15. You can only get 14. So I can order 14 bulbs. And that would be your answer. And once again, if we define our variables, we write an equation and we solve. Here's my solve. I had orange first, so I'm going to just go with that. Then if I wrote my equation, writing my equation would be right here. That's my B. And then my A, defining my variable, just kind of pointing these out to you so you can kind of see. I'll do that in purple. And here it is, number of bulbs. All right, last one. Nadia has $70 in her bank account. Each week she deposits $3 from her allowance and $15 from babysitting. How many weeks will it take her to reach $160 in her account? So, again, start with underlining the question. How many weeks will it take her to reach $160? How many, what am I looking for? Weeks. That's my variable. That's my X. I guess I could probably outline it in red and put X because it really stands for a number. I could do the same thing up here. So how many weeks will it take her to reach 160 in her account? 160, obviously important. That's going to be that end amount. So she deposits $3 each week from her allowance and $15 from babysitting. So how many weeks will it take her to come up with $160? And I best read the first part of this. It says she has $70 in her bank account already. So she starts with 70. So from there, so she starts with 70, and then each, if you go back to those word list, means multiply. Each week, well, right here's week. So week is our X. So each week she deposits $3 from her allowance, and she deposits $15 from babysitting. So she does two things each week. She deposits $3 and $15. So what does that look like as far as an equation? Well, first, define your variable. So, A would be, X is referring to weeks or number of weeks. Okay. B, what's the equation look like? She starts with 70. And then each week, we don't know how many weeks, so we're going to say each week. So we're going to say plus. We don't know how many weeks, but each week she deposits 3 from her allowance and 15 from babysitting. And then we want to know how many weeks does it take her to reach, there's our equal sign, 160. So equals 160. All right, so looks like we have some distributive property going on. So I don't know, let's do that in pink for today. So we have the distributive property. That kind of looks like that red that I got. All right, so we have 70 plus 3 times x, or x times 3, which would be 3x, x times 15, which would be 15x, equals 160. Or you could add those two numbers together because they're both numbers and get 18 and then multiply by x. Either way would be fine. But you're going to notice if we combine like terms, so if I go ahead and combine like terms right here, I can add those together, 3x plus 15x, which would be 18x. And you really can't see that, so I'm going to switch that back to, switch it here. So we'll make this 18x equals 160. and then plus bring the 70 down. All I did was combine those like terms. And now I can solve. I have a two-step equation. So I'm going to subtract 70. So that leaves me with 18x, bringing that down, equals 160 minus 70, which would be 90. Now I divide by 18, and I divide by 18, and x is equal to 90 divided by 18, which would be 5. So C, when I go to solve it, how many weeks will it take her to reach 160 in her count? It will take her 5 weeks. So it will take Nadia 5 weeks to earn the money, or something similar to that. So again, if I go back to highlight my defining a variable, my writing an equation is right here, and my C is it will take Nadia 5 weeks to earn the money. All right, real world situations with multi-steps.